Hello students, we are going to solve question number 3 of exercise 6.5. What the question is, we have to find the local maxima and minima and local maximum value, local minimum value of this function. So we have first function as fx equal to x square. The f dash x would be equal to 2x. To find the critical point, we make f dash x equal to 0, which would imply 2x equal to 0, and this would further imply x equal to 0. That means we have only one critical point, x equal to 0. Now when you go for f double dash x, the answer is 2. It is a constant function. So if I write down f double dash 0, this is still 2, which is positive. So when second order derivative is positive, the value of x is local minima, and hence local minimum value will be 0. So this is the answer to first part of question number 3, and this is the second question of question number 3. And this kind of question we have done in the class. We find first order derivative, which is 3x square minus 3, and make it equal to 0 to find the critical point. We get the expression in this way, and there is a term which could be factorized as x plus 1, x minus 1. Hence x equal to minus 1 and 1 are the two critical points. Now we find out second order derivative, g double dash x, which is equal to 6x. So g double dash minus 1 is equal to minus 6 less than 0. So therefore this would imply x equal to minus 1 is local maxima. Similarly, g double dash 1 is 6, which is greater than 0. So x equal to 1 is local minima. And accordingly, putting the value of x equal to minus 1 in the function here, we get the local maximum value, and putting x equal to 1 in the original function here gx, we get the local maximum value. The next question is a trigonometric function, and in trigonometric function the range of x must be mentioned. It is there. So we go for differentiating it. F dash x ddx of sin x is cos x, ddx of cos x is minus sin x. To find the critical point, we get f dash x equal to 0, which implies cos x minus sin x equal to 0. So this implies cos x is equal to sin x. Or to be more profound, we can write down tan x equal to 1. I have divided both sides by cos x. Now in this interval, at what point tan x is 1, that point is x equal to pi by 4 45 degree. So in this regard, I would like to mention, you can directly write down x equal to 45 degree from here, or you can also write down cos x by sin x equal to cot x is also 1, which will give us x equal to 45 degree, that is pi by 4. That is pi by 4 is the critical point. Now go for second order derivative f double dash x. Derivative of cos x is minus sin x. Derivative of sin x is minus cos x. So if we put the value f double dash pi by 4, we see that this is a angle in the first quadrant, and first quadrant mein both it becomes positive. So finally sin pi by 4 1 by root 2 minus cos pi by 4 1 by root 2, this whole quantity is negative quantity. When second order derivative is negative, then what happens? Or this value is the local maxima. So once we get the local maxima, we can write down local maximum value. Maximum value will be f of pi by 4. In the original form of the function, put pi by 4, that is sin pi by 4 cos pi by 4. Sin pi by 4 1 by root 2 cos pi by 4 1 by root 2, 2 by root 2 which is root 2. So this is the local maximum value of the function. In the next question we have fx equal to sin x minus cos x and the range for x is 0 to 2 pi. So f dash x would be equal to cos x minus plus sin x. This is our f dash x. To find the critical point, what we have done, we have made f dash x equal to 0. So therefore cos x plus sin x equal to 0. So cos x will be equal to minus sin x, or we can say tan x equal to minus 1. So in this interval 0 to 2 pi, which is a complete revolution, when we talk about trigonometric angle, we should always think about the 4 quadrant. So we are going from first quadrant to fourth quadrant, complete revolution. So in the fourth quadrant, at what quadrant tan x will be minus 1? We know that tan 45 degrees 1, so which will be first quadrant. We know that tan is positive in first and third quadrant. In these two quadrants tan is positive, but in second and fourth quadrant the tan is negative. So therefore tan of second quadrant is always pi minus theta. So pi minus pi by 4, which is equal to minus 10 pi by 4, class 11 ka concept. So this could be written as tan of 3 pi by 4 equal to minus 1. So from this we can write down one value of x is 3 pi by 4 because of this. Another value is in the fourth quadrant, tan is negative. As you can see the diagram, this is negative in the fourth quadrant. Fourth quadrant we take 2 pi minus theta. So I will write down tan of 2 pi minus pi by 4 is equal to minus 10 pi by 4. Okay. So this will give us tan of 7 pi by 4 equal to minus 1. So 7 pi by 4. So we got two critical points, 3 pi by 4 and 7 pi by 4. Now we will see at what point it is positive and what point it would be negative. So go for f double dash x. F double dash x equal to minus sin x plus cos x. Okay, it is f double dash x. So f double dash 3 pi by 4 will be minus sin 3 pi by 4 plus cos 3 pi by 4. We know that second quadrant में sin is positive. So this pi minus pi by 4 plus cos of pi minus pi by 4. In this case minus 1 by root 2 because minus a plus रहेगा. But in this case it is in the second quadrant, so minus 1 by root 2. This quantity is negative. Therefore x equal to 3 pi by 4 is local maxima. Okay, it is local maxima. Accordingly we find the local maximum value by putting 3 pi by 4 in the original function. So here it was minus, but cos of 3 pi by 4 is minus 1 by root 2, so minus minus plus. So root 2 is the local maximum value. Now we check the second order derivative at 7 pi by 4. Minus sin 7 pi by 4 means 2 pi minus pi by 4 plus cos of 2 pi minus pi by 4. So this is second quadrant में sin is negative. So minus sin pi by 4 plus cos pi by 4 because fourth quadrant में cos positive but sin negative. So minus minus it will be plus 1 by root 2. This is already plus 1 by root 2 and it's a positive quantity. Second order derivative positive, therefore x equal to 7 pi by 4 is local minima. Accordingly, our local minimum value is sin of 7 pi by 4. This is minus 1 by root 2, and cos of 7 pi by 4 it is minus 1 by root 2. 2 by minus 1 by root 2 is root 2. So I hope you understand the solution. Thank you very much.